So good afternoon, everybody. My name is Ismael Vasquez. I'm the technical sales manager with Carmelo. And today we'll be speaking about the structural concrete insulated panels. This is we manufacture these materials with Carmelo and our sister company in the US, GCT Gulf Concrete Technology, located in Long Beach, Mississippi. Carmelo is located in Sabana Seca, Puerto Rico. And so thank you very much for joining us as well. And today we'll have a short introduction. We'll have a description of all the SCIP components. We'll go over some of the applicable codes, building codes, we may say. We'll go over the thermal characteristics of these materials. We'll go over some of the construction also as well, and several projects that we have done, so you guys can get an idea of what type of projects you guys can do, and also the step-by-step installation and application of these materials. And we'll go over a little bit about the application of the mortar. And then lastly, we'll go into the questions. So Carmelo has been in the business since 1955. We started out with our masonry block plant, and in the 70s, we acquired 4 quarries to manufacture sand, and we have rock, and we also distribute a lot of aggregate to ready-mix producers and material suppliers as well. In the 80s, we started doing the flooring interlocking concrete pavers. And in the 90s, we manufactured the keystone retaining walls, garden walls. Then in the 2003, we started working with mineral additives like fly ash, and distributing that as well to the ready-mix producers and cement plants. Then in 2005, we started doing the industrialized mortars, back mortars, and we acquired the mortar application machine with Intech to spray our mortars as well. Then in 2010, we began manufacturing in Mississippi the structural concrete insulated panels, looking for energy efficient alternatives and how to make these construction a little bit quicker. Then in 2015, we added more specialized repair concrete mixes and mortars. I've been specializing myself in terms of concrete repairs for about almost 29 years there. Business with also worked with ready-mix producers as well. So a lot of great things here with Carmelo. And the structural insulated building components, let's say structural concrete insulated panels, was developed in Italy. All right, and these constructions have been in the market for over 40 years. So there's only one SCIP technology. We have used this in the US and also in Puerto Rico and in the Caribbean. We also have the permits with the government to use it in the US and also in Puerto Rico to get the permits for the construction and usage of building these buildings. And again, this product is very easy to install. It has a high design for hurricane and also seismic as well, and we'll go over some of the testing we have done for that. It achieves a high R value. I mean, that's the main let's say course here, because you can lower your temperature of your buildings. That's the main. So you have a cooler building, so your electricity bills will go down. Then we have done this in residential homes, commercial, industrial market as well, buildings. So there's a lot of structure we have done in Puerto Rico and also in Florida. And Hurricane Maria Irma passed by in 2000, let's say 17 with Maria, and we have structures that were dated back before that, and they withstand the hurricane winds. I mean, about 180 miles per hour at that time. So we have a pretty good record with hurricanes in our area. So we have two types of panels. One is called the PSM component, where the PSM starts with expanded polyester core, or we call it EPS out there, and then on the outside it has an electro welded wire mesh, right? It is a galvanized wire mesh. That would be your steel, and then we have a structural mortar after that. And over that mesh, it would be like 3/4 of an inch of a structural mortar, 4,000 psi mortar, and then lastly. You can either do a finished mortar, or you can do aluminum siding or other materials on the exterior as well, whichever or look you prefer. Then we have the PST components. The G stands for the girder, and those come again with the expanded polyester or EPS in the middle, right? And then you have your steel on the side, but in those 4 feet, you'll have a girder every two, if you say PSG2 or PSG3, every three girders per every 4 foot. Then these are used mainly on spans for, let's say, over 13 feet to about 32 feet. And we mainly use these on roofs, okay? So after that wire mesh, you need to put about 2 inches of 3,500 psi concrete, and then you're finishing. If it's in between slab, or that would be your roof slab as well. Now the PSM, I forgot to tell you guys that they go from, let's say, you can do a span up to, let's say, 12 feet, 12 to 13 feet, right? You can also use them on roof that's without any supports. Those 12 feet or 13 feet. And also we mainly use them in walls. That's where you're going to use the PSM. So the steel that we use is it's a 95 KSI steel, very high tensile strength. And you have let's say an 11 gauge wire going every 3 inches, right? On longitudinal to the strength of the let's say of the board, the length of that board. And then the transfer secondary mesh, that's about 12.5 gauge, and that runs about 2.5 center, you know. So then also in between those 2 wire mesh, you have the foam. So there's also a wire that's going to connect them every 6 inches, or every 6 rows. Okay, and that has a gauge about 11. So that's a little bit to discuss about that steel. And then our mortar that we use is it's a 4,000 psi mortar, and these we have a pre-bagged mortar that we manufacture in Mississippi or in Puerto Rico as well, and they contain additives and good properties there. We use our Intec machines like the Monomix or the Duomix, where we spray our mortar with low pressure, and our mortars are designed to be used with these machines. So it's great to spray your walls, or let's say your ceiling. Then the mortar characteristics, these mortars have to have 4,000 psi 28 day. Okay, it has to have an aggregate about 3/16 of an inch. And that's the main course there. In terms of building codes, we meet, let's say, with the International Building Code. Our system is designed to meet the building codes out there as well. And you can see all the properties, especially the ASTM E84, where you have a test method for surface burning characteristics as well. And So we comply also with the design and standards of the building codes. Also, the impact and test resistance standards as well. We're going to talk a little bit about that in a minute. Then we have, let me move this out of the way. Okay. Sorry. We made a project up there in Antarctica, and this would be the base Esperanza, where they needed to finish this job in about 3 months because due to the daylight they had, and they with our system we were able to finish that job in those 3 months, all these units. And then in Africa as well, they benefit from the heat that's outside, and it's good now. It's going to be cooler inside of these buildings, so you can use it in freezing areas and also in hot areas as well. So just to give you an idea of how low your temperatures will be inside the building, we use this light and emitted a, let's say, heat about 132 degrees, and then we directed that heat to a wall of concrete, 4,000 psi concrete, right? And on the side of that heat, it's about 100, and wall, that'll be 109 degrees. Then on the other side of that wall, it's going to be about almost 90 degrees, right? That's about a difference, about let's say 19 degrees. And then if you look at our SCIP or structural concrete insulated panel, again, you start in your surface about 109 degrees. Then you see how the foam mitigates that temperature going down to 72 degrees. That's a difference about 36 degrees. So now what would be the difference between both, right? It's about 17 degrees already there. So your R value, and that's what the industry calls for, R values run from 12 to 34, and that depends on the thickness of our panels. They go from PSM 80s to PSM 240, right? So here's a table with the sizes. Let's say the PSM 60, 80. You can see the 80 is one of the most panels that we use for walls. They have an R value about 12. And then our 240 for the PSM is about 34. Then with the PSG, the one that has the girder, they run from 20 to 36. That would be your roof, where you have that isolated heat, you know. So that's your R value there for those panels. Then tests that we have done to our structural components, right? We have done lateral testing for seismic loads as well. We have an R value as well as I like 5. Some of those structural engineers out there would know that. And it has a real high strength and reliable for seismic loads. There's also a projectile impact test, 201 and 202, where they shoot a 2x4 wood, and then it shoots at about let's say 80 foot per second. And so the idea of this test is that whenever you shoot that over the surface of a wall, no material can come out on the other side, and we have passed that test. So this is required by the Miami-Dade and also the Florida product approvals, right? And in a lot of states in the South and in the U.S. also go with the Miami-Dade testing. So we with our system we have complied with those. Let's say whenever there's a hurricane or high winds as well, you know, we comply with those walls as well. Also, we have done ballistic testing, and that's especially on federal buildings where they want a level 3. It provides protection for a 40-foot Magnum rounds. So you can see here, this testing is that they shoot at the wall, and so nothing comes out on the other side, and that's how the way you either pass or fail. You can see there that no rounds pass the other side of the wall. So how do engineers and structural engineers design, and architects design with our system? We have taken all these tests, right, and put it on a report. This was done with GRJ certification, right? This is what we call a technical evaluation report, and our last one here is the 120212. And this was done especially for our GCT insulated concrete panels. Okay, so this is equivalent for those civil engineers out there, equivalent to an ICCES report, and this has all the physical properties for them and dimensions, has the R values, it has the structural capacities, and then we also have some reference tables where, depending on the supports, right, you can also select the panels. So this is a very important document, and we can also email it to you if you're interested in one of these copies. We also have it in Carmelo.com, a copy of this manual. And DRJ is known all over the states in terms of certification. So for structural and architects out there, this is what we're sending out for design. Also, for the government permits as well in Puerto Rico, we have had the approval for construction as well in Florida as well, and in other states with the government where you can get your construction permit and the use permit as well. So on your left side here, this is how when you're putting up your panels, right? And then this is how the way it'll look. You see the foam, the steel as well. How in the corners we use our L's and fix those to each side of the wall or ceiling. You can see the rebar coming up from the slab where we use the dowels, and then on the right side, this is how your house is going to look, or building is going to look with your finished mortar and applications in the exterior. It's going to look like a normal home or a normal concrete home, let's say. So what's the difference between doing it with our SCIP system versus regular forming or block system? Look at the difference in these pictures where you're going to have less labor. It's going to look cleaner. You're going to have a safer environment. You don't need any cranes or anything to move around these forms. And this will facilitate, again, the work of the crew. Here you can see how these guys were very optimistic, where they took 3 panels and they wanted to move 3 at a time. But we recommend to move 1 panel at a time, so it'd be quicker and faster. Let's say. See on the top, they're putting up blocks. In a good day, 2 guys can put about 300 blocks. In our panels, you can put up to, let's say, 1,000 to 2,000 square foot of these panels. So that's what we call 10 times faster than doing it with regular blocks in concrete as well. It requires less staffing. I can do a house with just 5 people. And again, you have fewer security risks out there. Things falling on you, heavy things falling on you, where these panels just weigh only about 35 pounds per square foot. So you can do all kinds of projects, right? These are an example of some of them that we have done. You have Royal Isabella. These are houses, a housing complex here. Here's another one. See, they look like regular, concrete homes once you finish it. This is in Cabo Rojo, and this is an interesting one because an architect built this one. That's his home, and he built it before Maria, the Hurricane Maria, one of the hardest hurricane here in the island, and it would stand those hurricane winds, and also this one there we had a seismic about six, and and also withstand the seismic isolation where there were no cracks on this building. So I mean, also you look at the span you can also use without beams or columns here as you can also use the PSC panels for that. So I mean these houses look like regular concrete houses, like you can see here. Once you apply your finish mortar, or this was a tiny home we did. It's about 400 square foot, and we did it at 17 days. We took out the house that was an existing house, and then we replaced it. I mean, we gave literally the key to the customer in 17 days, and we had two rain days. So that was very quick. This is in the waterfront here in Arroyo, and here these were built in 2016, and the Hurricane Maria went over them, and nothing happened to them. They still look like new. So you can do also rounded shapes. You can do pools. You can do rounded areas as well, like here in these pictures. And this residence is in Mississippi, so you can also do either concrete or aluminum siding as well, whichever finish you want to use, stucco as well on the outside. And this one is in Florida. Yeah, got a concrete home here. It looks beautiful there, real modern. And this is one of my favorite house and place. I wish I could own one of these, but yeah, this one was completely done with our panels there over there in Florida. So imagine, I mean, right now there's no scale. I mean, you can with these material you can go up to, let's say, 4 buildings high, or unless you're using let's say concrete reinforced concrete columns or and beams, and then you can go up higher as well and use our system as the shell. Okay. So how do we build these? Let's start by the foundation. How do we're going to go step by step here on how to build these. And the first, I mean, you usually do like a typical foundation, concrete foundation. You take out your soil, right, and to do your beams on the bottom, and you put your vapor barrier there, so there's no moisture coming up from the soil. Then you put your rebar on the top, right? You use all your reinforcement beams there, and then you can also put your dowels for your panels. But again, we prefer to drill in those dowels instead of having it from the beginning, because like here you can see some of them are bent, and then it's a little bit kind of hard to put the panels. So, but again, it's your choice. So let's look at this construction of this foundation. Here on the right, you see the dowels were already put from the bottom here, and from the bottom of the slab. So that these are going to go down, let's say, into the concrete 7 inches. Then from the concrete up, the surface is going to be, let's say, what we want is 18 inches. And so we're going to have 2 rows of rebar. But these are going to be staggered. You put one in the corner, then the next one comes in at 8 inches, and then every 16 inches you put one. Okay, so they're staggered about every 8 inches, and then separated on each side every 16 inches. Okay, so you can either do it from the slab, um, already reinforced, or you can again drill a hole and put epoxy, and then stick the rebar on those holes. And here are two types of construction in slabs. On the left here, we have a wall in the middle, and this would be your rebar, regular slab here, how to reinforce it on your foundation. And then here on the right, you have your typical details. We have a lot of details, drawings for those engineers and architects out there. We can send them out, and you can also use them. So here on your right, you got to remember that whenever if you're going to do, let's say, a 1-inch stucco on the exterior of this foam, right, or this panel, you have to make sure you leave that edge right there to 1 inch, and that's where you start. So let's say if you're using a PSM 80, in between wire, you would, let's say that's about, let's say, 4 inches. So now you have to measure how much mortar you're going to put over that wire, let's say 1 inch. So that's how much you have to be away from that edge, so that it all comes in a straight line for that exterior wall. Okay, so then you mark where you want to put that wall, with a chalk line. That's the first thing you do, and then you drill the holes, and every 16 inches you're going to put a rebar. Okay, on that. Here on the left, they had already put the rebar from the slab, but on the middle of this picture here, this is how we let's say drill the hole and then put the rebar, right? Okay, so you can either do either or. Again, you can either come from the bottom and put those dowels from bottom up and into the let's say the concrete, and then, or you can either drill a hole on the slab, and then so that your panels are stuck on those two lines of rebars. So once you put your panel, these panels come in, let's say, 4 feet by 10 or 8, depending on the height of your wall, all the way up to 20 feet you can do. But the rebar, you got to use tie wire, right, to tie those that rebar to our steel on the outside. And then you would burn, let's say about behind the rebar about one inch, so that concrete goes. Once you pour the concrete or the mortar over this surface, there's enough mortar, protecting the steel. Okay, and here we have on the right somebody with a hand hot click gun, but this one is just manual. And we prefer to buy one that's pneumatic. You just use a 90 psi compressor, and it'll be quicker using that. So how do you install these panels? So you start off from the corner, right? And you want to close them like in a square, so they're firm and they're not dangling due to the wind, right? So you start from the corner, then you put one, then you put the other, where you have the rebars, right? Over that. Then once you come into the corner, you go to the other wall, like you see here on the right. And then you close that, and then again you can close it either this way, closing it by rooms, or here you can see how is it done. You see the rebar with the panels. We usually leave the windows for last. So if you have extra panels, you can either put them here, or extra cuts. Then you can go in and close in the windows, and let's say, and here you have a beam for the door as well. or header there. Again, you can see how they're putting it. And the other way is that you start from the corner. That's another way to put the panels. Is you start from the corner, and then you go in one by one until you meet the next wall. And you just put one there, and then you just keep going on to the next wall, and then finish. So that's another way to do it. So what is the best way to cut the rebar on these panels? And the best way is to use let's say either a lock cutter or a plier, at least 2-foot plier, right? And that would be the best way, because if you use let's say a diamond disc, it's just going to take a little bit longer. You're going to use more disc than necessary, right? You think you're going to go faster like that, but doing the plier method, it's much quicker to cut them. Okay, because again, this is a high tensile 90 KSI steel, and then with your regular saw, you can cut the foam and you'll be done with it. So either you use the plier, and then you use the saw to cut them, right? You just make sure you spray or mark where you're going to cut them, and that's it, on the field. Let's see. So you're putting here, they're putting 3 panels at a time. Again, I like putting them one by one, but then once you have more experience, you probably want to produce more, right? So, but you can see how light these panels are. I mean, just with 2 people, you can move them around. Okay. And again, it's very important that you shore these panels so that the wind is not moving them. You got to plumb these panels first, and then use wood to shore them as well. It's very important to use these safety buttons here so that the rebar out there for you guys, you don't fall over these rebars. And again, you can either use wood, you can either use aluminum. That come pre-made as well. These types of shoring. So how you align and plumb the panel? Okay, you put your let's say your first board there. That would be like 2/3 of the height. That's where you want to put your first board there, and then you either use nails or screws to hold them down here on the floor. Okay, or you either use a steel gadget like this or aluminum, where they already come in for that, and that would be much easier as well. And the main thing is that you plumb here on the right, plumb and pin up. Make sure that you use a 6-foot level, and you want that level to be as straight as possible. You want 90 degrees to the floor. Okay, and then that's where you're going to use your hot clip gun, and you're going to join every single panel when that is plumbed. Okay, so but the main thing is that if you're going to catch, let's say a 2x4, you want your wire to go to the other side of the steel. Okay, this is very important, so that this will be a more sturdier or fixed bracing. Here they're stitching the wires. I mean, you're gonna put a clip every 2 squares or every 6 inches. These panels come with an overlap about 2 squares, and what you do is whenever you match them, on each side of the wall, you'll be able to stitch these with a hot clip gun, and they're called the C clips. They're about 1/2 inch. Okay, I can send you the model that we use as well. Now this one in the right is the one that we sell, the hot clip gun. And again, with a 90 psi compressor, you're using and moving real quick. With the one here, manual on the left, I don't think you'll last an hour doing that, because you know, using the pneumatic gun is much quicker and easier for the labor out there, and they don't cost much. You know, you can either buy it from us or from Amazon. That's okay. Um, so. Uh, then we have the accessory mesh for reinforcing and connections. This is where how you connect your roof with the walls or wall to wall. So there's three kinds of mesh. We have one called the corner mesh, the RG1, uh, and that one is the one here on your far left. And they come in 7 inches with for the interior, and also for the exterior meshes where you have a joint, you're going to have a 7 by 12. So wherever there's a joint in between those two panels, that's where you're going to use the 12-inch side. So you have a good overlap on that mesh. Then we also have the flat mesh, the RG2. These we use either to expand the panels, or if you make a cut for, let's say, putting a pipe or for electric or plumbing. Once you cut that pipe, you put it in the panel, and you have to again fix whatever you cut, and then you put that flat mesh over that. They come in about 1.5 feet by 4 feet, and we also have 4 by 4 and also 4 by 8s. And last but not least are the RGU or UU mesh. These will go in the perimeter. Will be on the perimeter of the windows and doors, and or wherever the let's say the foam is exposed. We want mesh on that surface. Okay. And this is the configuration how you put them. So you got your corner mesh here on the left. It can be from wall to wall. Okay. So you're on the right. This is where you use the 7-inch one. And here you let's say you have a roof to wall slab, and this is where you're going to use the long side. See the joint when you're joining two panels together. This could be a wall to wall or a roof to wall. Okay. So you want the long side, the 12-inch side on the exterior. Okay. So in the interior, you're going to use the 7 by 7 mesh. And again, they come in a 4 foot length from the factory. And for the flat mesh, we use it. I mean, you can take a 1.5 by 4 foot. You cut vertically in half, both of them in half, and let's say in vertical and horizontal. You cut that mesh 1.5 by 4 feet, and for every mesh you have like that, you can put 4 pieces on the outer side, so you're protecting and reinforcing those corners on the windows. Okay, so with one panel, you can do 4 sides like that, and then you'll need another panel for the other side. Okay, it's very important that whenever you do the windows, you leave the let's say the hole of the window. It has to be like 3 inches more than what you need. So you use your wood. You can use wooden frame to do that. Okay, in between the foam and that mesh, there'll be like let's say 3/4 of an inch. But then we need at least 3/4 more that on the outside, right? To make that perimeter strong, right? So you have a strong perimeter around that window, so you can put your top gun or top or your screws, you know, there, so you can nail your windows to the or screw your windows to the to that mortar. Okay. And again, are the PSG3 slabs connected? And this could be either your PSG2. It has 2 girders. So here in the bottom, you can see the PSG3 has 1, 2, 3. girders, and in that girder, you're going to put two number two rebars in that girder, right? Plus, you have to separate the rebar, so you need some separators there to so that the rebar is not over the foam. So here you have a diagram on the right. So you got two number four rebar. That's a half inch, and then on the bottom, the first thing you do whenever you're doing a roof slab is you put your mortar, and it has to be 3/4 of an inch over the steel, and then when that dries, then you can go over and put your 3,500 psi concrete over that. So you got to call your local ready mix producer for that concrete. That's where you're going to put concrete on top. And so these comes in PSC 2, 3, and 6. So every 4 foot, a PSC 3 will have 3 girders. A PSG 6 will have 6 girders here. And so depending on the size of that the panel, the thickness, also and the length. So it'll be the span that you'll cover, and or the panel that you'll need. Here you can see the bond beam. This is just I wanted to show you the bond beam here with how it is reinforced, right? Here they put an L here into the panel, and then you have your rebar, right, with your rings, steel rings here. Every whatever the structural engineer has put them every 6 inches, every 4 inches. It all depends on the design of the structural engineer for those bond beams as well. So that's how you lock those PSG panels. So and you can see how easy it is to move them around. You don't need any cranes, right? You can go over them. And again, they have to be sure to walk over them as well. You have to have good shoring, and I'll go over that in a minute. So here, this is the length of the panel, right? So what you want to do is whenever you're doing you're putting up your shoring, right? You're going to have a 2x4 or 4x4, whatever you use, or it could be aluminum again. You can put those up, and it has to be transverse or perpendicular to the length of the panel. That's very important to know. It has to be perpendicular, so that, and then you're going to leave from the wall 2 feet, and then every 4 feet you come in, or unless the structural engineer tells you something different, how he wants those shoring. Okay, but that's what we mainly call for, every 4 feet. And then when you're next to the wall, you're like 2 feet from there with the shoring. Okay, so that has to be perpendicular to the length of that panel. Okay, I'm sure you remember that. And here's a picture of it, right? So that your panels are running on one direction. You can see the joint here. You can see the light, right? You see the piping. We already had put the piping there before we shored it, right? Be sure that you do that first, and connected all the panels in between. So you see your 2x4s, or it could be a 4x4, and then again it has to be transverse or perpendicular to the length of that panel. Here we're showing you the how we use the heat gun whenever you have a box, electrical box, or the piping or plumbing, and how you burn around it, and that's how you're going to put your boxes and fit the pipes, right? So you're going to use one of these heat guns, and again, the heat guns they can go from $40 to $80, depending if you like brands or not. And they go for, let's say, from 500 degrees to about 1200 degrees. Please do not use torches to burn the panel, because then you're gonna make a hole, and then you're gonna lose your isolation, right? So the way they put the boxes is that they put mortar around the boxes first, and then you just stick them out depending on where you're gonna have your surface of that mortar, right? Of the finished mortar. And you can see how the runs are done here with the flexible piping. See here, you can on the right, you see how they 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 melted the foam, and you can see how they placed the water piping here. See, this is your water piping on the right and the electrical piping on the left. And it's very easy to do. And again, once you open up the mesh or you cut the mesh, you have to put the let's say a flat mesh over that cut. And one of the things we do, and this is very important, over the mesh, you should be putting some guides to whenever you're putting your screeding, doing some screeding of your mortar. Put some guide, I'd say every 3 or every 4 foot, depending on the size of your screed. Okay, and we use, let's say, a 1/2 inch 40 gauge pipe. It can either be plastic or it can be galvanized, and you just put them every 3 or 4 feet, and that way you over the mesh, and that way you have the 3/4 of an inch mortar that we want, the structural mortar that we want over that. Okay. Here you can see how they place those guides. Okay. And again, I prefer to start from the bottom. You know, the mortar. I mean, hello, it's gravity. Gravity falls. So you start from the bottom up. You know, you don't want to start from the top to the bottom. That's why we show this. Okay, how not to do it right or wrong. Right. You start from the bottom up, from left to right. Okay, and you start going up, and then you use your screed and you finish up. Okay. So this is very important. You know, steps by follow these are the steps to follow to put your roofing, right? So the first thing you do is you apply your layer of a structural mortar on the walls on both sides. Okay, you need your structural mortar 3/4 of an inch on each side of the panel. You spray that first, and then you you apply the structural mortar to the bottom face of the roof, right? On the ceiling. You do also over the mesh 3/4 of an inch. Let that set. Okay. Then you can go up and pour the concrete that you need at least 2 inches of cover over the mesh of concrete. Okay. Then while the concrete cures, you can apply your finish mortar on the walls. Then you remove the roof supports system, not less than 7 days, or depending on what the structural engineer says in his specifications, right? And so you have to wait for that structural capacity or compressive strength of that concrete as well. So you got to wait either a minimum 7 days, right? And then you come up and you're probably with where you had those supports, you'll come up and then finish with your structural mortar, those areas that you missed. Okay. Here we have a video of how the mortar is placed. You got so you got guys starting to place also on the other side, on the left side, we use a trowel, a notch trowel, let's say 1/4 inch by quarter inch, um, and um, and we make lines from left to right. So that way we have a mechanical bond. So when you're going to do your last mortar finish, that'll be like a 3/8 of an inch mortar finish. Then that will stick to the surface. So you won't need any bonding agent for that. So let's take a look at how we place the roof. So you got less rebound with our materials. That's why we use Carmelo structural mortars and the finished mortars as well. They cover all your boxes and I'm sure you cover them. Okay. So here you're seeing almost the finished product here. This is again the 400 square foot house, mini house we did here, that we turned in 17 days. And also, again, the structural mortar, we need it to be 3/4 of an inch over the mesh. That'd be on each side of the walls and also on the ceiling. And again, use those guides, a half inch or schedule 42. You can use to get that 3/4 of an inch diameter of the mortar as your guide for the screen, right? And also, once you finish your structural mortar, then you can place the 3/8 of an inch finish mortar, right? Type N mortar. It can be type S, or it can be a stucco, or it can be aluminum siding, depending on what you prefer as exterior coating. And then these are our MTech machines. These are what we use to apply our mortars. The monomix. This is one of the ones that we mainly use for housing buildings. And it's 220. I mean, where you can turn on your stove. That's how you can use it. And then you can either use the monomix or the dual mix is some more productive, but again, it has a three-phase. You need a big generator to have that voltage there. But the one that we mainly use is the monomix, and this one projects about 550 bags a day at a half inch. Imagine, I have contractors down here applying about 300 bags in one day they can do. So that's excellent. So for every day you use this machine, you're going to save almost 3 days of labor instead of using, sand, cement, people carrying with wheelbarrows. That's how efficient these systems are. So this machine, you place the bag on the top, it mixes this here on the through the sleeve, then it goes into a 32-foot hose, and then you'll project at the end. We sell these machines as well, and we also rent them. But mainly in the US, we sell them. So if you're on a roof, again, you need a minimum of 2 inches on the edge of that roof. I mean, if the roof is flat, then you need for every foot you need like a 1/4 inch slope, right? So you got to go up a 1/4 inch. So if you have a 10-inch span, and that's 10 inch, sorry, in a 10-foot span, you'll have about 4.5 inches of concrete. Your 2-inch minimum plus the 2.5 inches that you need for the slope to go down. So it'll go from 4.5 inches in the center to, let's say, 2 inches on the sides. That way you have a slope on those flat roofs. But if you have a real steep slope roof, all you need is just 2 inches over the rebar. Okay, and again, try to walk over the wooden planks underneath that, or you're shoring underneath, or over wood. So you okay. And these are some of the configuration drawings that we have, and that we can also provide to you guys as well. And this is how you see it on the field, right? You can use you can have your sloped there. You can have your flat roofs as well. So here, so to finalize, here are some of the projects that we have done, and again, the houses look like if they were made of concrete, in which they are, structure, but now they're reinforced. This is an industrial building we made. These walls are over like 18 feet. Okay, look how they shored them. Okay, and these are chilies that we have made as well. We have done several of them as well. They wanted to use the silo because they had a lot of bags that we can fit about 1,000 bags in that silo. And then with the machine, you just have to not even break it. You use the pump and then spray it. Again, 18-foot walls. And thank you very much for your time. I don't know if you guys have any questions. You can open your mic to speak to me. If you have any questions with that. And again, we have technical support sales in the US and in Puerto Rico. We got Scott Miller in the US. And this is his phone number. I'm Ismael Vasquez. I'm a bachelor's degree in civil engineering, and I'm here in Puerto Rico and in the Caribbean, but we also help out, structural engineers in the US as well to design with these. We also have Victor Camacho as well, our PE in our company, and he can also help you out with any design questions as well. So these are our phone numbers and emails. And again, you can go up to our website, carmelo.com, and look at all of our products as well, and also download, let's say, the SCIP manual or a technical evaluation report as well. Or if not, you can send us an email at info@carmelo.com, and we can provide you with whatever information you need with these panels. Okay, I got a question from a contractor. Should the intersection between roof and walls always have an EPS removed entirely or just partially? Okay, intersection between roof and wall. Actually not. I mean, roof and wall, you're going to have your panel connected right directly over that panel. So you don't need to put any concrete or additional beams in between that, unless the structural engineer says something different. That's the main thing. So it's going to go. So the wall is going to just join that panel with that slab, the roof slab, directly over that, and then you put your angle, mesh on that. Good question. And again, if the structural engineer does not put a beam or a column there, you don't need it, because every foot of this panel is either a column or a beam. It's already a reinforced element. Well, I really appreciate your assistance to this webinar. Is there any test report about? Yes, we have the technical evaluation report that we can send you. We have test reports there. We can send that. Please email me at info@carmelo.com, and I'll get you whatever testing you need. If you need one in particular, let me know. But I can send you the technical evaluation report where it has the testing performances on there. Well, I really appreciate your questions. And again, if you have any doubts or questions, you can either call Scott, myself, Ismael Vasquez, or Victor, or email us at info@carmelo.com, and we'll try to answer all your questions and help you out with the quote of the materials, and also get you that's either a design for that housing that you need as well. And so really appreciate your assistance. And will you provide a copy of this video? Yes, the video will be we usually post these videos in our website, and also they'll be available in YouTube. Okay, so you can look at them later as well.